Okay, so the outline of what we're going to cover today is shown on this slide. We're going to talk about the main concepts involved in an Apex application, um, and then briefly describe the application we're about to build today called the sorted word count. Then we'll do a hands-on demonstration of cloning the source repository for Apex. There's actually two repositories there. One is the Apex core, and the other is a library of operators, pre-built operators called Malhar. Then we'll do a hands-on demonstration of building a new application and then running it. And if we have time, we'll do a quick walkthrough of one or two source files. And then hopefully have some time left over for questions. The main concepts that are involved in an Apex application are operators, directed acyclic graphs, ports, and streams. So operators are Java classes that need to implement the operator interface. Each operator has input and output ports that are connected by streams to form a directed acyclic graph, which is sometimes called a DAG. The input port receives data from upstream operators. The output ports send data down to downstream operators. Within an operator, you define fields whose type is either default input port or default output port. And these are very simple classes that implement the appropriate interfaces, providing empty functions for abstract methods. The base operator class is very similar, but meant for use to create your operators. The application class needs to implement the streaming application interface, and only one method is involved there, populate DAG, and that's where you instantiate your operators and you wire them together to form the DAG. Applications process data within time-based windows. Typically, that time-based window is half a second, 500 milliseconds, but that's also configurable. Okay. For the sorted word count application, we're going to feed it a plain text file that has some English text, and it will compute word counts for all the unique words that appear in that text file, and then output a sorted list of pairs, the word and the frequency, sorted by the frequency in descending order. So there's about 5 operators involved. The line reader simply reads the file that's dropped into an HDFS input directory, and then splits it into lines, which are output on the output port. The word reader does something similar, but for each line. It splits each line into words using a regular expression, and outputs those words to the next operator. The window word count computes and emits word frequencies for all the words in the lines coming into it, and when the end of the current window is reached, which is typically, as I mentioned before, a half a second, so every half a second, it will write out the entire map of words to the frequency counts to the next operator, which is file word count. File word count is keeping track of the global counts. So it accumulates all the word counts from the current file, and finally, when it gets an end of file, it will emit the sorted list on its output port, And finally, that data is received by the word count writer, which writes out the list to the configured output file in the output directory. Here is the excuse me. Okay, here's the diagram showing the DAG. So the 5 operators that I mentioned are here in these boxes. These streams are labeled by the appropriate words, lines, words, window word counts, or file word counts. Notice also that there's a second stream going from the line reader to the file word count. So that's used to transmit the end of file tuple when an end of file is encountered by the read line operator. Okay, so that concludes the slides portion of the talk today. So I'm going to switch now to the hands-on portion. Okay. Here, a word about the environment in which I'm working. This particular machine is a Windows laptop on which we have VirtualBox installed. And using that, we've created a virtual machine that's running Ubuntu Linux 16.4. So if we go here and type lsb release -a, it should show the actual version of Ubuntu that's actually running. Now, into this virtual machine, we also need to install Hadoop. So you simply go to the Apache Hadoop website, download Hadoop, and follow the instructions there. And once you've successfully installed Hadoop, you should be able to run the JPS command. So JPS is a built-in command that comes with the Java distribution. It should show you that there are a bunch of daemons running. So JPS is like the PS command on Unix systems, but it only shows you the Java processes in a more user-friendly way. So here we have a total of 6 Java processes running. The middle one, JPS, is the command we just ran, so that's not very interesting. But the data node, secondary name node, node manager, and resource manager should all be running. If those are not running, you won't be able to run your Apex applications. In addition, to build your application, you'll need a couple of other tools. Obviously, you need Java. So here, if I type java-version, it shows me the version of Java that I'm running. But not only do you need the Java runtime, but you also need the Java JDK. So one way to check that you have the JDK installed and not just the JRE is to run the Java C command. You see that I've got version 1.8.0 of the Java compiler running. You also need Git in order to clone the repositories. So git -- version shows you the version of Git that I've got installed here. And finally, you need Maven. So Maven is a build tool for building typically Java projects. So the command line command for it is mvn. If I type mvn -- version, it should show me the Maven version that's running. That's all the preliminary setup for starting with our application. Now, if we look here, let's start with a fresh directory. I'm going to create a directory called work and step into it. And I'm going to copy over a couple of files that are useful. One is called New Project, and the other is repos.sh. Okay, so repos.sh is simply a set of convenient variable definitions, shell variable definitions, for the GitHub repos that we will be cloning today. So I've got Apex Core, Apex Malhar, and Apex examples defined over there. Okay, so let's get to work. What we'll do is we need to source this repos.sh shell script file so that these variable definitions become effective in our current shell. And the way you do that, of course, is just source repos.sh. And now if I do echo $apex core, you'll see it shows you the value of that variable. So what we do is the standard git command for cloning a repository, git clone, and then $apex core, which will substitute the value of that variable. Change the spelling mistake there, clone, and there we go. So Git is starting to fetch all the data. It takes about a minute or two for the for Git to complete its clone. Let's wait for that to complete. As I mentioned before, the core Okay, so what's happened here? I've lost my... Oh, okay. All right, so the clone was successful, and you see the Apex Core directory created over there. Let me repeat that process for Apex Malhar, which is the library of operators. So the Malhar library of pre-built operators is quite a bit larger than the core platform. So the download takes a couple of minutes longer than the previous one. This library can actually save you quite a bit of time when it comes time to building your actual production quality applications, because it provides you with connectors, pre-built connectors. By a connector, I just mean an operator that can connect to an external system. So there's connectors for connecting to JDBC, databases, message queues such as ActiveMQ or Kafka, and HDFS file system, and many, many others. So the whole often painful process of connecting to these quixotic external systems is already taken care of in these pre-built operators. In addition to that, We have the third repository called examples. We're going to clone that once this one's finished. But let me just show you what's in that examples repository. So if you go to GitHub, github.com, data torrent, examples, you'll find there the contents of examples look like this. And within that, there's a directory called tutorials. So if you click on tutorials, it will take you to this collection of directories, and typically one directory per example application. So the examples that are present so far are, you can see it's quite a list, and more are being added almost on a week-by-week basis. The list here is sorted alphabetically. So you can see there's a variety of examples showing how to do file I/O. Then there's one showing you how to read from an HDFS file and write to JDBC. There's also one that reads from HDFS and writes to Kafka. JDBC ingestion, reading from JDBC and writing to HDFS. Or here we have reading from JDBC and writing to JDBC. So there's lots of examples here, and depending on your particular excuse me, use case, I would encourage you to browse through these and pick up whatever example is closest to the application that you're building. All right, so here it looks like the Malhar cloning is also complete. And if we do an ls, we can see there's Apex Core and there's Apex Malhar. Let's also clone the third repository, which is the examples, Apex examples. This one is pretty small, so it should finish pretty quickly. Okay, there you go, it's done. All right, so our next step is to build Core and Malhar. So let's step into Apex Core. And if you do an ls, you see there's a whole bunch of directories and files. So the thing that's important if you don't know about Maven is this pom.xml file. So this is the build file that controls how the building happens using Maven. So Maven automatically looks for a file with that name, pom.xml. So we'll just build it by typing maven clean install -d skip tests. So clean just removes any earlier artifacts you might have that are part of an older build. In this case, we don't have any, but it doesn't hurt to have that option. Install, it's worth noting that install is not actually installing anything into system directories. So you don't need to be a administrator or a super user in order to do the install. All it's doing is installing the artifacts of the build, which is most often jar files, into your local repository. So your local repository is, let me switch to a different console, is typically in your home directory under a directory called .m2. So if I list that directory, you'll see it has a subdirectory called repository. And under that is where the installation goes. Okay, so the skip tests, these repositories have many unit tests, and they take a long time to run, for which we don't have time now, and we don't really need to run them here. So it just says to skip the unit tests. Okay, So let's give it a shot. It should chug along and build it. And you can see it will automatically download any dependencies that your build requires. So if your build requires certain packages from third-party libraries and they're listed in the pom.xml, it will download those. So the very first time you build these repositories, it can take several minutes because of having to download all of these repositories. And you do need to have an internet connection while doing this. In this case, however, it shouldn't need to take too long because I've run this command before, so most of the jar files should already be in the local repository, but it still goes ahead and checks. So there it goes. It's building the Apache Apex. I wish it had some kind of a display showing what percentage of the build is complete, but it doesn't. But hopefully it should be done in a minute or so. Okay, here it's compiling the engine. The engine is the core of the core repository. Okay, it's close to being done now that the engine is compiled. There's also some check style definitions in there to make sure that everybody checking in code follows at least a few consistent code style guidelines. And some of the time taken here the very first time is making all of those checks. Now you can see it's completed. Let's do the same now for Apex Malhar. This can take slightly longer because, as I mentioned before, the Malhar library has a lot more code than the platform. So here we go. We're building it and installing it in the local Maven repository within your home directory. Okay, while that's going on, let me show you a couple of other things. If you've installed Hadoop and Yarn correctly, you should be able to go to their consoles and view them. So the console for Hadoop is the local node port 50070, 50070. So if you just go to that location, it should show you this kind of a page with a green banner on top and a variety of information showing how much of the Hadoop file system is in use and various statistics related to that. It also shows you the directory where HDFS is installed on this local machine. If this page doesn't show up, that means there's something wrong with your Hadoop installation, and you need to troubleshoot that. Okay, now once the HDFS is installed, you need to install Yarn as well. And if Yarn is installed, you can go to the Yarn console, and that's port 8088. So if you go to localhost 8088, you should see this console. And earlier, I had run the application just as a sort of a dry run to make sure everything is working okay. And that's what's shown here. It shows you that a particular application is run, sorted word count, and notice that it gives you the state as killed and final status as killed. So that application is no longer running. When we create this application and run it again, you'll see a second row in this table. And in general, you'll see all running applications or all running applications as well as all applications run recently shown in this table. The other thing that's useful on this console is if you go to the Tools section, there's a local logs. So that shows you the log files for a variety of the Hadoop daemons. And if something goes wrong, you'll need to go into these log files to see if there's any exceptions. The one particular log file that's useful is the resource manager log. So that's this one. The name of the file may differ on your machine depending on what you've named your virtual machine or your cluster nodes, but generally speaking, the list of files will look somewhat similar. Notice also that there's a user logs subdirectory. That's where the logs for the individual applications are stored. And here you see some old applications that I've run before, as well as the application I ran earlier today, which is no longer running. Typical Yarn applications have an application ID that looks like this. This long string that starts with the word application underscore and then a long number followed by an underscore and then a few zeros followed by a number. So that last part is actually the actual application ID, but in many contexts you'll have to use that entire application ID. Okay. Hang on just 1 second. Somebody's asked a question asking if this session is being taped for review later, and the answer is yes. It is being taped, and we will publish this in some place where everybody can get to it. Okay, so let's back up to the Yarn console and check the status of what's going on with the Hadoop build. Okay, so it looks like it's building some of the demos within the Mulhar repository itself. In addition to the examples repo that I mentioned, in the Mulhar repository itself, we have a bunch of demos which are more substantial example programs, and I would strongly encourage you to look at those as well, because they address different use cases. Okay, so let's go over here to the other console, and let me show you this other file that I copied called new project. So what this new project is is just one Maven command. But because it has so many arguments, it's convenient to stick it into a shell file so that you can modify it later and rerun it if necessary. So what this command does is it uses what's called an archetype to generate a new project. So in Maven, there's ways of setting up templates for a project, and that's what an archetype is. So in this case, it uses the Apex archetype to generate a full mini project for you as a starting point. So once we run the script and generate a sample project, we can then go in and add appropriate source files to this project to actually build our real project. So it gives you a starting point because a Maven project requires a particular directory structure, and in particular Apex requires certain files to be present in certain places. So all of that is nicely taken care of by this archetype. Notice also this variable here called v equals 3.4.0. That reflects the current release of it reflects the current release of Apex. So actually, this is slightly behind the times because 3.5.0 has actually been released of both Core and Malhar just in the last few days. So if you like, when you're trying this out, you can change this V to 3.5.0 and go through exactly the same steps, and it should work exactly the same way. So notice that V variable is used over here, where we have this archetype version equals $V in quotes. That's where it's used. So you can actually not even use the V variable and stick in the version right here, if you prefer. Okay, let's see if this Malhar is completed building. Yes, indeed it has. So both of these have finished. So let's go ahead and run this template creating Maven command. So if you have a shell script, you can run it very simply by just saying bash and then the name of the script. Before I do that, let me show you what we have in our work directory so far. We have the 3 repositories that we cloned as directories, and we have the 2 files that we copied over from elsewhere. Now, after I run this Maven archetype command, you should see a 4th directory containing the project that we're going to be working on. Okay, so let's do bash new project. All right. Okay, we have that command is finished, but we have a question I just got asking, what is how is Apache Apex different from other tools? So it would take me too far afield to talk about the use cases for Apex, but let me very briefly say that Apex is a platform that allows you to build distributed applications for dealing with big data. So it can deal with both batch as well as streaming data. The main focus really is streaming data because that's becoming more and more important. The difference is that batch is potentially large amounts of data that's already present in some store. Like, for example, the HDFS file system, you might have a file that you need to process. That would be an example of a batch processing system. Streaming, on the other hand, means your application needs to deal with data that has no beginning and no end. It just continues to stream in. And an example would be a clickstream from a popular website. So if you have a popular website that's being used by millions of people, they're looking at it worldwide 24/7, clicking on various pages, and the results of those clicks are streaming in. And you need to process those clicks to figure out what is the geographical distribution of usage, how are people clicking on which links, all sorts of analytics need to be computed dynamically while the data is in flight. Another example would be data coming in from IoT systems, Internet of Things. So if you've got a power system that has a windmill farm, every windmill, for example, has hundreds of sensors. All of that sensor data is streaming in, and you need to process it in real time, for example, to figure out if any of the windmills are in bad shape and might need a service call to fix them. So that's a short summary of what Apache Apex lets you do. Earlier systems typically were batch-oriented, whereas Apache Apex is really optimized for the streaming case with very low latencies and very high throughput. All right, so if I now do an ls -L, you see the fourth directory that I was talking about. It's called My Apex App. Okay, so if I switch to My Apex App, you'll see the pom.xml that I mentioned before, as well as a source directory where the source files are located. Now, this application is a ready-to-run application. It's very simple. It has only two operators, one of which is a random number generator, and the other is an operator that just writes its input to the console. So the random number generator will generate random numbers and stream them in to the console operator, which then sends them to the console. So pretty much a trivial application. But its value is that it sets up all the Maven infrastructure and machinery that's necessary to build, much larger projects. So let's go ahead and build this. Very similar to the way we built the Apex Core and Apex Malhar, but with a slight difference. MVN clean, and this sample application we don't need to install in our repository. So instead of install, I'm going to type package, and then the -d skip tests. So what this will do is, before I do that, yeah, okay, we can do this. So notice that we don't have a directory called target. Once I run this command, it will create a directory called target and put into it all the artifacts of the build. And those will be the .class files generated by Java, as well as the jar files and the application package files, which have a .apa extension. Okay, so let's do this. This will be pretty fast because there's not much to do here, just a couple of files to compile. There it goes. The warnings are not significant. You can just ignore those. Okay, it's finished. And here's my target directory. And if we look inside, you'll see that there's a whole lot of generated directories and files, but there's this APA file. This is the critical artifact that we need in order to launch the application. What we'll do now is we won't bother launching this trivial application, but rather we'll copy over some source files that I've already prepared to save us some time here to do the word counting, and copy them over to the appropriate spot. So let's step into src, and you'll see the main directory, and within that there's Java and resources. Under resources, there's a directory called metainf, and within that there's a properties.xml. That XML file can be used to configure your application. So if you need to set up like input directory names and output directory names, stuff like that, specific configuration for various operators in your application, that's where you do it. If we have a little bit of time, we'll take a look at that file. Right now, we want to go into Java, example my Apex app, and look at the files there. So there's the two files. The random number generator that I talked about is there. There's also an application.java, which has the populate DAG method that I mentioned in the early part of my slideshow at the beginning of this talk. The console operator actually comes from Malhar, so there's no need to have a file for it here. All right, so what we're going to do is, if we, I'm going to switch to this other console and then go to the examples directory. Under examples, I mentioned tutorials, and there's top N words. And if I go there, there's a directory called webinar. And you see there's a whole bunch of Java files there. So what I'm going to do is copy these Java files over to my new project. Okay, so copy over that directory, and then in this other console, type the cp command, star.java, to here. Now if I do the ls-lt, you can see that it's copied over a whole lot more files. We have the application.java that we had before as the bottom two files, and the others are the new ones. And these are the operators that I already briefly mentioned at the early part of this talk. The line reader reading from a file, the window word count, the word count writer that writes to the file, the word reader that splits a line, and so forth. Okay, so we have these files in the right spot. Let me now do one more copy operation into that metainf directory. So if I go into resources and the metainf, here's the properties file that I mentioned before. So over here, I'm going to copy over one additional file that was present in that source directory, and that's properties-sortedwordcount.xml. So the way these properties files work is you can have a file called properties- and the name of the application.xml, and those properties will then apply only to that application. whereas the properties.xml properties there apply to all applications in this project. So a single project can actually have multiple applications. And in this particular examples, we actually have two. We have the original random the random number generator project that was automatically generated, and we also have this new word counting application that we're building now. Okay, so let me copy that over here, and you see now we have the two files in the right. Okay, so let's go ahead and move to the top level directory and rebuild the project. Since we've added new files, we need to rebuild it, and in particular, we need to rebuild that APA file, which is what we want to run. Okay, so let's run the Maven command again. Okay, so while that's going, let's switch to Apex Core. Actually, we don't need to. Well, that's fine. Work/Apex Core. Okay, so under Apex Core, there's a shell script called Apex. So let's look for it. So if I do find, and then dot, and then name Apex, it will find it. So there it is. It's under engine, source, main, scripts, Apex. So that shell script is the one you need to run in order to actually launch this application. So let's copy over this path to our other console. Okay, here we are in the My Apex app directory, and notice that the build is successful. If I do an ls-l of the target directory, you'll see that the .apa file has been recreated. And notice it has a timestamp of 1748, which is right now, just a minute ago. Okay, so we're in good shape here, and that's the file we want to launch. The way we launch it is by running that shell script from work Apex Core / and then we want to copy over this path, engine, source, main, scripts, Apex. Okay, so let me paste that here, and that should run. There we go. So it shows you the version, and it gives you this Apex followed by this angle bracket as the prompt. So this works as a sort of a custom shell for Apex. So over here, you can type help to get help on all the various commands that are involved here. The number of things you can do is quite extensive. You can not only launch applications, you can look at the status of applications, you can list applications, you can actually dynamically modify applications by removing operators, adding operators, and hooking them up in a different way, and then restarting the operator. So this command line tool is really very, very flexible. Okay, so now what I'm going to do is launch the APA file, and the APA file is located under target, so I'm going to say launch target / star.apa. But before I do that, let's step back a bit and look at our HDFS setup. So to look at what's under HDFS, you typically use the HDFS command. So HDFS DFS-ls, and then you can give it a path. So in our case, this application reads and writes files to /temp /test. Oops, TEST. So if I do that ls command, I should see what else is, what's in that directory right now. There should be nothing there, and indeed there is nothing there. But if I do the same thing for /temp, it should show you that there is a test subdirectory, and indeed it does. Okay, so for this application, it requires a pair of subdirectories under temp test. So let's go ahead and create those. HDFS DFS-mkdir, which is the typical Unix command for creating directories. Temp test input dir. So that should create the input dir directory. Okay, successful. And then let's create the output directory, output dir. Okay, those two are created, and now if we repeat the ls command on temp test, we should see the two directories that we just created. Both of those are empty, there's nothing inside them. Okay, we're ready to launch our application now. So we go back to this other console and we run the launch command. I can do a star.apa because there's only one APA in the target file, and that will typically be the case. You typically won't be building multiple APAs in the same project. All right, so if we hit this, it should take maybe a minute or so, and then come back with an application ID. Oh, actually it gives us a prompt because, like I said, there's two applications, so it wants to know which one do I want to run. In our case, we want to run the sorted word count, so I'll give it 2 and hit return. So at that point, it'll chug along for a bit, and it should come back with an application ID. There we go. So this long string here, application underscore, and this long number followed by 002, that's the application ID for the running application. And right here, I can do list apps, and that will list all the applications that it knows about. So the return is a JSON file, a JSON structure, I mean. And notice that it prints 2 records. The first one is the earlier dry run that I did earlier, and its state is killed. The current one shows a state of accepted, and this is the ID 2. Okay, so the application is now running. If I go here to the Yarn console, and if I refresh the page, you should see 2 applications here. There we go, the killed one and the running one, which we just started. All right, we're ready for this application now to process our input file. So I'll go here, and then I have in my share directory, I have a text file, which is prideandprejudice.txt, which is the text of the novel by Jane Austen that I downloaded from the Gutenberg project. So that's what we'll use as our input. So I do the HDFS command to copy it over to HDFS, and that's done with put. I say ~share/Pride and Prejudice, and I want to copy it over to temps test input dir. Okay, so it's copied it over. Now let's run the ls command, the HDFS ls command on the input dir, just to verify that the input file is in fact present. Okay, so it shows you the Pride and Prejudice.txt file. So the file is present in the input directory. Now let's see if it's completed processing and put something into the output directory. We do the same thing, but instead of input dir, we do output dir. Okay, there it is. We have this file with the same name, Pride and Prejudice.txt, created in the output directory. Remember, the output directory was something new we just created, so there was nothing there, but now we have a new file. Notice also that the output directory is much smaller than the output file is much smaller than the input file. That's because the output file only has the words and their frequencies. So let's double check that. The way you look at the contents of an HDFS file is by using the cat command, and we do output dir slash and then the name of the file, prideandprejudice.txt. Okay, but this cat, it's going to dump a whole lot of lines, and we don't want to see so many lines, so I'm just going to pipe the output to the head command, which will only print the first few lines. Okay, there we go. The command is successful, and it shows me that the English article the is the most popular, most common word with 4,218 occurrences, followed by various prepositions, conjunctions, and things like that, these small words that tend to be very, very common in any English text. So as an exercise, I would encourage the audience to try and modify this application so that these common words are excluded from the word count, and it only prints the uncommon words that are not excluded. Okay, so that completes the presentation for today. If anybody has any questions, feel free to type them into the question panel on your screen. Otherwise, I'd like to spend just a minute showing you the properties file. Okay, we come back here. Our Apex command line tool is still running, and I'm going to get out of this by typing exit, and then step into SRC main resources and the meta-inf. Okay, so here's the properties files. So if we look at properties-sorted word count.xml, you'll see it's an XML file that's got configuration as the top level element, and then some stuff that's commented out. Notice that there's this container JVM options. So the important thing to remember about these sorts of distributed applications is that each operator runs in its own JVM, potentially on its own node in a cluster. So this is actually a collection of applications that are working together as a single application. So if you want particular JVM options added to the way your operators are run, you can add them here in this property, and then uncomment this property. Moving further, the way the word reader, notice the way these properties names are specified. It's dt.application, that's a fixed string, and then you have the sorted word count as the name of the application, and then you have the literal operator, and then the name of the particular operator, in this case word reader. So the word reader needs to be able to split words. So how does it know what's a word and what's not a word? Well, this non-word str is a property that I've built into that operator, which should be a regular expression telling the operator what's not a word. And it will use this to split words. So in this case, the regular expression says anything that's a punctuation or anything that's white space acts as a separator between words. The next property is the line reader directory. This is the directory monitored by the line reader operator. And as I mentioned before, and as we saw on the command line, that's temp, test, input dir. You can change these to monitor a different directory. And this again, temp, test, output dir is the destination directory to which the word count writer will emit the word counts, frequencies. Every Yarn application has what's called an app master. That's a separate process that serves a supervisory function. And that container needs a certain amount of memory, so you can configure that memory over here. For all of your operators, the memory consumption can be controlled by this memory MB parameter. In this way, I've set it to 128. 128 is actually pretty small. For production applications, that will need to be often 1 gigabyte or 2 gigabytes or something like that. Okay, I think I will stop here. Thank you very much. I hope you enjoyed the presentation. And we will make the playable video available somewhere. I'm not sure exactly where, but if you monitor the page apex.apache.org, you should see links to these webinars over there. Thank you very much, and happy apexing. Goodbye.